Hi everyone! In today's video, we will be talking about finding the distance between 2 points on a coordinate plane. To help us find the distance between 2 points on a coordinate plane, we're going to do a quick review on the Pythagorean theorem. Remember that the Pythagorean theorem applies to right triangles, and we use it to relate the length, the width, and the long side, which we call the hypotenuse. And the Pythagorean theorem says that the squares of the length and the height will be equal to the square of the hypotenuse, or a squared plus b squared equals c squared. So if we know a and b, then we can find c, or if we know any combination of two sides, we can solve for the missing side. So for instance, if a equals 4 and b equals 3, then we would say 4 squared plus 3 squared equals c squared. 4 squared is 16, plus 3 squared is 9, and we get c squared. 16 plus 9 is 25. And so c squared we know equals 25. To solve for c, we're going to take the square root of both sides. And so we know that c equals 5. Now we're going to apply this to a coordinate plane. If I give you 2 points on a graph, we should be able to use the Pythagorean theorem to help us find the distance between 2 coordinates. So now let's do an example. If I asked you to find the distance between 2 points, let's say 2, -1, and -3, 1. How would we do that? Well, let's start by plotting the points. If we start with 2, -1, remember that it's always x, y. And so we'll go to the right 2 and down 1 for our coordinate here. -3, 1 is to the left 3 and up 1. And what we're trying to do is find the distance between those 2 points. So what does this have to do with the Pythagorean theorem? Well, if we treat the distance between the 2 coordinates as your hypotenuse, or side length c, we can draw lines that are parallel to the x and y axis through each of the coordinates to make ourselves a right triangle. So we have our length of A and our height of B. What's our length A? The length A is the difference between your x coordinates. So going from -3 over to 2. And how many spaces is that? 1, 2, 3, 4, 5. So we know that our length A is equal to 5. We can do the same thing with B to find the height. From -1 to +1, we see we go up 1, 2 spaces, and so B is equal to 2. Now that we know 2 sides of your right triangle, we can use it to find the length of the hypotenuse. And so remembering our formula, a squared plus b squared equals c squared. 5 squared plus 2 squared equals c squared. 25 plus 4 equals c squared. And so we know that c squared equals 29. And to find c, we would take the square root. And so c equals the square root of 29. Let's try another example. If we want to find the distance between the coordinates 2, 5 and -3, -4, how do we do so? Let's again plot the coordinates down to help us visualize the problem. Plotting the points 2, 5, we're going to go over 2 and up 5. And for -3, -4, we'll go left 3 and down 4. Once again, we're trying to find the distance between those 2 points, and we're going to treat that side as our hypotenuse, C. And so we're going to draw in your intersecting lines that would be parallel to the axis to get our right triangle. The length, or the distance between -3 and 2, is again your change of x, which we'll symbolize like so. And we know that the difference between -3 and 2 is 5. For your height, b, or your change in your y, we know that the distance from -4 to 5 is 9. And so using our Pythagorean theorem, we know that 5 squared plus 9 squared is equal to c squared. 25 plus 81 is equal to c squared. And so we get 106 is equal to c squared. Take the square root of both sides, and c is equal to the square root of 106. Now, we don't want to graph our coordinates every single time, but we can use the same idea for any sets of coordinates. So let's do one more example where this time we won't graph the points. If we're given the coordinates 10, -18, and -1, 6, how can we find the distance without drawing a graph? Remember that we're looking for C, or the hypotenuse, and we can use the coordinates to find the length A and the height B. We talked about the length, which is A, being the change of x. What does that mean? Well, we want to look for the distance between 10 and -1. And so we know that if we counted from 10 to -1, we would get 11 spaces. The same thing for the height. Which we have been calling B. We can find that by using the change of y, the difference between the y coordinates. If we count the spaces from -18 to 6, we would get 24 spaces. Really, what we just did there was subtract. To find the change of x, all you need to do is take the first coordinate minus the second coordinate. 10 minus -1 is equal to 11. The change of y is just the subtraction of two y coordinates. So we'll do -18 minus 6, which gives us -24. Now the reason why we don't have the negative in our original number is because distance is usually measured in positive numbers. And so we always take the absolute value of our number. In this case, because we're using the Pythagorean theorem, it doesn't really matter because when we square a number, we'll always end up with a positive. And so if we do 11 squared plus -24 squared, we'll get the same answer as if we used 11 and 24. 11 squared is 121. 24 squared is 576. And so when we add them together, we get 697. And so C is equal to the square root of 697. Using this concept, we can now derive what we call the distance formula. Where c, the hypotenuse, is considered the distance, which is the shortest length between any two coordinate points. We just said that if we treat the length like your hypotenuse, then we know that the distance between 2 points, or again what we call c, squared, is equal to the length squared plus the height squared, or what we've been referring to as A and B. We know that to solve for C, what we'll need to do is take the square root of A squared plus B squared. And really what we've been talking about today is that A is just your difference in your x coordinates, and B is just your difference in your y coordinates. And so one more way to write this is just taking your x coordinates and subtracting them, plus your y coordinates, subtracting them, and we square both of them to get your distance. And thus we've derived the distance formula. But really all we're doing is using the Pythagorean theorem and solving for c. Thank you for joining me today and learning about the distance formula. I hope this video has been helpful for you. Let me know in the comments what topic you'd like me to cover next. See you next time.